Greetings. Today we're going to discuss pest identification, the cornerstone of integrated pest management. My name is Dr. Mary Burrows. I'm the Extension Plant Pathology Specialist for Field Crops at Montana State University. I'm also the State IPM Coordinator, and I run the Scudder Diagnostic Laboratory. And we'll talk about IPM today, and we'll talk about the Scudder Lab. First, I want you to think about where do you go to get your pest questions answered. So what kind of pest questions do you have? Today we're going to talk about integrated pest management, so I'll give you a little introduction. We'll talk about the plant disease triangle and a little bit about plant disease cycles and how we can use these to manage plant diseases. And then we're going to discuss how to submit a sample to your county agent or the Scudder Diagnostic Laboratory for diagnosis. We'll also discuss how you can diagnose things yourself and some of the benefits and the risks of doing digital diagnostics or diagnostics using photos. First, let's define IPM. IPM is a sustainable approach to managing pests with a combination of tactics. So we use biological, cultural, physical, any means necessary to control a pest below what we call an economic threshold, or the threshold at which it's causing economic damage in a farming situation. The goal of IPM is to make sustainable enterprises, whether that success is defined by having economic success, environmental success, or any other sort of success. IPM is synonymous with organic often, although organic uses a lot of the same tools of IPM, but organic production does not allow for the use of synthetic pesticides or synthetic things of any nature such as fertilizers. So that's the main difference between IPM and organic production, but we use exactly the same principles, including accurate identification of the pest. There are 4 key concepts of IPM. The first is prevention, the second is avoidance, the third is monitoring, and the fourth is suppression. So for prevention, obviously we want to prevent the pests from infesting the crop or the field. In order to do this, we can use both federal and state resources. So there are organizations such as the Department of Agriculture and APHIS PPQ that help us prevent diseases, insects, and weeds from coming into the state. They have regulations in place to help with that. We can also use pest-free planting material. An example of this would be your potatoes that you grow either in your home garden or in a larger scale. There's here in Montana State, we have the Potato Lab, which tests potatoes and distributes pest-free tubers to people for production. And then one of the other examples would be planting resistant cultivars to prevent. You say you get a pest year to year, you can choose resistant cultivars from the catalog or from university data or industrial data to help reduce the damage that that pest is causing to your crop. The second principle is avoidance. So avoiding the pest of concern. And so this primarily uses cultural techniques such as planting date. You can plant earlier or later to avoid when you know that peak is going to be, or you can use resistant varieties, which is also prevention. The third principle is monitoring, so looking for the pest of concern, so scouting, using weather models to predict when the pest is going to occur, or just knowing what weather conditions the pest of interest prefers, so you can look for it. You can also be a member of several listservs that we'll talk about later that might alert you to what pests are important in your area during a particular time of the year. And monitoring also includes nutrient monitoring. You can do soil tests or tissue tests to help make the healthiest plant possible. The last principle is suppression. It usually is the last thing used as an IPM strategy. in terms of pesticide application, but suppression also uses cultural methods of suppression. For example, you can exclude a pest using barriers. Physical suppression, like roguing plants out. If you notice they're diseased, you can pull them out or till them in. Biological control or pesticide-based tools to help reduce the pest populations. These are the members of the IPM program that went to a meeting in 2016. Pictured here are both the on-campus faculty, such as you can see Cecil Tharp here, who's our pesticide safety education, Lori Krasinnik, who's our insect identifier, Noel Orloff, who identifies weeds and native plants, Eva Grimmie, who does mostly the urban plant diseases. We also have Jane Mangold, who works on invasive plants in more rangeland systems, Fabian Manalid, who does crop weeds, and then we also have several county agents as members, who are actually 2 of them are former county agents now. We have an evaluator. We also have members of the Department of Agriculture, Ian Foley, and the federal APHIS PPQ, Gary Adams. So at this meeting, we have stakeholders also, including our Master Gardener representative, and the representatives change from year to year, but we have both on-campus faculty and off-campus faculty, and we get together at least once a year in a big focus meeting to help plan and meet the needs of our stakeholders. So if you have any questions about IPM, feel free to contact any of us. We're happy to help. And these are largely the people that'll do your pest identifications and help provide some of the management strategies on your operation. So since I'm a plant pathologist, I always include the disease triangle in every presentation. The disease triangle are the principles of how to control a plant disease epidemic or plant disease problem. So in order to have a successful disease, for a pathologist that means having disease, you need a host, a pathogen, and a favorable environment. So the host is obviously the plant that gets infected by the disease. The pathogen is the organism that infects the plant. So you obviously have to have a pathogen present in order to have a disease. And then the environment is the favorable environment. And so based on what disease it is, what weather conditions or situations about like relative humidity or temperature would favor the disease. In order to manage the disease, you have to eliminate one corner of the disease triangle to eliminate the disease. So if we're talking about host, we could either use crop rotation to not plant that host that year. Let's take an example such as tan spot of wheat. In order to not grow, you would not grow wheat or any other susceptible host if you wanted to manage it. We know that the pathogen lives on the stubble of wheat. So anything you can do to eliminate the stubble from the field would reduce the amount of pathogen present. And also we know a lot about what environment the tan spot organism favors. So it likes it warm and humid, above 75 degrees and very high relative humidity. So we can alter that environment by either planting plants less thickly or maybe reducing irrigation if it's an irrigated situation. So once we understand what disease we have, we use the disease triangle to help control it. You can also Google what is called the disease cycle, like say tan spot disease cycle, and you can look at where the disease, how it survives and how it infects the plant and what weather conditions favor disease development in order to understand the disease and then help target control. So for example, I mentioned that the pathogen survives on the stubble. So that is in the disease cycle, and then you can target management at the disease, at where the pathogen survives, which is the stubble. So I supervise the Scudder Diagnostic Laboratory. We identify about 2,000 plant diseases, insects, weeds or plants, mushrooms, and toxic molds every year. We answer all kinds of interesting questions. About 50% of those are homeowner, horticulture, landscape, and about 50% of those are in agriculture. You can go to our website at diagnostics.montana.edu, and on there you can find instructions for submitting a sample. You can download the forms, and you can also find our contact information. This includes email, phone, and we even now have Facebook and Twitter accounts. You can also find a donate here button if you really like our services. You can provide a financial contribution to help with the sustainability of the lab. On that website, there's that donate here button. We do have some fees, although largely it's a free service. If we have specific tests we need to perform, we will charge just to try to recoup the materials costs for that. And there are some other guidelines on the website which you can find. Last year, we processed 3,500 samples, and we had an economic impact of 4.8 million estimated due to clients implementing recommendations and that's only on 73 of those samples. So we have a pretty big economic impact, but a lot of our impacts tend to be not economic. They're more helping people identify it, and they feel better, they feel more confident. Which is not an economic impact, but we do try to help people as much as we can. We are a member of a national system for diagnostic laboratories. There are 169 in the United States that help with the National Plant Diagnostic Network. These go all the way from Alaska down to Guam. And we are kind of in the middle of nowhere. You can see we're right here in Bozeman. Our closest diagnostic labs are Fargo, over here that's Sioux Falls, and then Idaho, and then there are some labs in Washington. But since we're so remote from most other diagnostic laboratories, it's really useful to have us here so we can give recommendations that are very relevant to the Montana High Plains environment. And we work very closely with the whole diagnostic lab system to get accurate identification of pests. For example, if I get a question on sorghum pseudoangrass, I'm not necessarily the sorghum expert, but I am good friends with a pathologist in Kansas that works a lot with sorghum. So I contact him directly, and he helps me when I need it. And having that network is really, really useful to us. We've gotten a lot of resources through them that we wouldn't have otherwise. Part of that National Plant Diagnostic Network is an opportunity online to become a first detector if you're concerned, especially about invasive species. First detectors are the people on the front line, on the ground, that first notice that odd thing. So if you're in the field and you notice an insect like a metallic beetle you think might be an emerald ash borer, you could collect that and send it to us for accurate identification. So first detectors are the most likely to encounter new pests. You can receive first detector training and go on this registry, take some online modules at the University of Florida. You basically attend presentations and classes just like this one. You have to be alert for the unusual or different and get your questions asked, get things properly identified. You'll be placed on a national notification registry, which basically means I think you get a quarterly newsletter by email. It's not at all threatening, although it sounds very official. And you will receive pest alerts and other relevant updates. The modules in the crop biosecurity course include the mission of the NPDN, monitoring for high-risk pests, diagnosing plant problems, submitting diagnostic samples, photography for diagnosis, and then disease and pest scenarios. So feel free to visit that website if you'd like to get signed up or want more information about the First Detector program. So relevant to Montana, what invasive pests are on our horizon? What we expect our first detectors to find first. The first one listed here is Japanese beetle. Japanese beetle has actually been established in the Billings area near the airports for many, many years. But that's the only place in the state it's thus far established. We had a scare a few years back where a nursery from Minnesota basically shipped a lot of landscape plants without properly treating them into Montana, and they were released in at least 9 urban centers in Montana. But to my knowledge, none of those populations after the release have established in those areas. So that's good news. But the APHIS PPQ and Department of Agriculture are constantly monitoring for Japanese beetle. Other ones on our horizon include brown marmorated stink bug, the Asian longhorn beetle, and emerald ash borer. Currently, we are just monitoring for these. There have been no positive identifications of any of these species in Montana, but do keep your eye out for them and be sure to, take pictures or submit samples if you think you found one. Others we have monitored for include sudden oak death, the pale cyst nematode, potato wart, UG99 stem rust, wheat blast, and Sharka or plum pox virus. These are ones we're always surveying for, helping the Department of Ag and APHIS PPQ with some specific tests they need to perform for these during routine surveys. And we have connections with other diagnosticians and scientists throughout the US, Canada, and throughout the world to help prevent these from becoming a major issue in Montana. You can go to the Hungry Pests website, which is run by APHIS PPQ, to see what current pests are of concern. Most of the APHIS PPQ people tend to be entomologists, so there's quite a few bugs listed, not so many diseases and weeds, but don't worry, we're looking for the diseases and weeds too. Every year we find new ones to us coming into the diagnostic laboratory. An example of one of those, which actually didn't come into the diagnostic laboratory, but one of the Department of Agriculture officers was fishing with his son and found this eastern heath snail. Its scientific name is Xerolenta obvia. And you can see it here covering grasses. It also covers fence posts. When it was first identified, it occurred in Michigan and then Montana. So it's obviously an introduction that had moved here, we don't know how, either contaminated hay or equipment, most likely. And it's very well established all throughout the Montana. And actually, this is a map of their survey in 2012. After that first identification, they did a survey and basically found it along all the roadways. It possibly had moved during mowing operations. That seemed the most obvious because you can wound these snails with a mower, but you cannot kill them. They're very, very hardy. And this is one day's collection by some kids. They had a snail roundup in the belt area, and that's how many snails they collected that day. So quite a large biomass. Another example would be the invasive mussel that we've are currently, you may have noticed a bunch of boat inspection stations. And in the latest update is that the infections have been confined to the Canyon Ferry Reservoir and Tiber Reservoir thus far, and no adults have been found as of last week. And this is September of 2017 that I'm recording this webinar. But obviously we want to prevent the spread of mussels throughout Montana. Some successes from the diagnostic laboratory include finding the small hive beetle. This was sent in by a curious beekeeper. It had only been found in, I forget what countries, but there's a nice article here at the Oregon State website about the small hive beetle. And APHIS PPQ decided that they did not have the resources to regulate it, but it now has become an economic pest in Oregon. And anything that is infesting hives is a threat to our honeybee industry. We did have an explosion in the spotted-winged Drosophila populations a number of years back. There was a big explosion all over the U.S., and you can see that first detection in Montana in 2011. And we did work with the cherry growers, and now we assume that spotted-winged Drosophila is established in Montana. And another one is pea rust. You can see that here on the right. I forgot to mention that this is a picture of the small hive beetle here on the left. But this pea rust was actually sent in by one of our research centers. And this is actually on vetch, the alternate host. And it provided us an opportunity, even though this is not an invasive pest, it's fairly established in the U.S., but it gave us the opportunity to know that this could occur in Montana and to prepare some educational resources to help growers manage it. We know as a result of our communications with other states that it's not going to be an economic threat in the majority of cases, but we do have information on how to recognize it and how to manage it. So one of the most important things you could get from today's presentation is how to submit a good sample for pest identification. So not only do you have to submit a good sample for pest identification, you also have to give us good information to get a good diagnosis. I get a lot of samples into the clinic that I've identified based on the zip code on the box that was sent to us. At very minimum, I want you to give me your name and your telephone number, because the first thing I'm going to do is call you and figure out what the situation is. People often don't know what information to provide, but we do have sample submission forms on the website to help guide you through what we're looking for. Those submission forms are also available at the county extension office. And please write legibly if you submit a form. We really, really appreciate that. But what kind of questions do you ask if you're asked to identify a pest? One of them is the history. When did it occur? Have there been any chemical applications or drift possibilities? Has there been any insect activity? I'll give you an example. I grew fava beans in my garden this year just to see what they would look like, because I know that fava beans are kind of on the horizon as a new big crop in Montana. And I wanted to see not only what they look like, how they grew, but also what diseases could occur on them if I was lucky enough to get any. You got to remember, I'm a pathologist. And one of the things that happened to my fava beans is that they turned black. And this apparently is what fava beans do. I brought a sample into the diagnostic laboratory just to see what was going on. And we found that, I knew there was a lot of insect damage on the plants, and at those insect feeding sites, there was a lot of bacteria. And when the tissue gets infected, it turns black, which is very concerning, but very normal for fava beans. And you'll see that if you grow fava beans, that the pods themselves just turn black when they're maturing. So it's a normal thing for fava beans. And to me, it wasn't very concerning, but now, I know going forward what to look for. We'll also ask you a lot of questions about what the pattern is. Is it an isolated plant? Is it the whole field? And I'll give you an example from just today. I got a cowpea sample into the diagnostic laboratory. It was in a cover crop mixture, and they were concerned that it had virus-like symptoms. They had narrow leaves with very strappy symptoms and a mottling on them. But they told me that it was 100% of the field was infected, which to me says that it's not a virus symptom. I also noticed on the plant that the plants had emerged just fine, and about 3 nodes up, the leaves looked just fine and normal, and then they turned all branchy and strappy. So that to me also suggests there's some sort of herbicide issue. Whether it's a residual herbicide or some drift situation, we're still figuring out, but a whole entire field will not turn like that from either a seed transmitted or an insect transmitted virus. So that's me being able to help a non-expert in plant pathology with identifying their problem. So we're still working on that one, but we'll get there. We can also ask if there are any differences in variety. For example, in that cowpea field, the mung beans were fine. So that's why they think it wasn't an herbicide. So we have to figure out if cowpeas are differentially sensitive to some herbicides. And then you can also ask if they use certified seed or if they got the seed tested for diseases. It really just depends on what the situation is. You have to have lots and lots of questions in order to properly diagnose a plant disease or insect situation. There are forms on the website. Fill it out with as much detail as possible, but remember, at minimum, I want your name, not just the company name. I want somebody to talk to and a phone number. And I'll text you if you want, that's fine. And you can put prefer text on there if that's the way you want to do it. But we really need good contact information to ask more questions. Put that form in the box with the sample and take it to the county agent as soon as you can, or just send it to us directly, and that address is listed right there on the form. So here's some good samples. You can see we got whole plants. That's really important. We do not need a whole tree. A branch is fine, but we have received whole trees in the past. You'll note that the roots here are wrapped in plastic, and that helps keep the fresh plants. The principle would be that you want to collect the plants and deliver them to us that we could plant them in the greenhouse and they'd survive. That would be an ideal situation. I don't care what kind of plastic you use. You can use a baggie, you can use a garbage bag, you can use one of those AI gloves. I don't really care. Just some sort of plastic, and then wrap it with some tape or zip ties or anything you have to keep the soil away from the foliage. And this is because when you put that in a box to be delivered here, the postman does not handle it with white gloves very gently. It's going to get knocked around in that box. So just keep that in mind if you're shipping it. Do not ship it on a Friday, especially when it's really hot out in the summer or really cold out in the winter, because things do boil and freeze on that mail truck. You can often just start with a picture. So again, don't put the bag all around the whole plant. Put the soil separate from the foliage. That will be helpful to us all. We often get what we call box damage, and especially if the plant sits in the box all weekend. We love getting photos to show the situation and field patterns if possible. And we have lots of tips for digital photos, and they're really important because we want to be able to help you as rapidly as possible. So take a variety of pictures. With digital pictures, there's no limit. We don't have to deal with film anymore. Take a picture of the situation, take close-ups, and send us just the best ones. You don't have to send us 20 photos. Just pick 2 or 3 of the best ones to start with. We'll ask you if we need more. Have enough light in the photo. I get a lot of pictures that are just too dark. I have some growers I'd really like to just buy a new phone. Include the features of the organism or problem so that they're clear and in focus. For example, if you're sending a spider, send a clear in focus picture of a spider or a ladybug or whatever it is. Make sure the problem is clear. I'll show you some examples of where it's not very clear. Focus, focus, focus. Make sure that it's in focus. Include a size reference if you can. Sometimes it's the house. Sometimes it's just throwing a quarter next to that bug, so we just can get a relative idea of size since we're not looking at it with you. And then use a neutral background where needed. And again, I'll show some photos where that's really, really well done. So I'm going to give you the good, the bad, and the ugly of digital diagnostics. These are really good. In the upper left here, this is stripe rust on wheat. It's very good in focus, and I can even tell that this is probably a resistant variety because of the way the lesions developed and the presence of these black spores. Down here, this is a very susceptible variety to stripe rust, although there might be a bit of a resistance reaction in there. This one on the right is a single plant. Then we'll follow up so we can see the situation. It's a single plant. The plants around it look okay. And then we can follow up with more questions where we need it. This is a really good one because not only did I get a picture of the plant, seeing that the problem was that it was yellowed, but I also can see this constriction right here. And here's a close-up of that constriction on the pea root, which tells me that it's a root rot and the problem exists at the soil line, which suggests to me it's rhizoctonia root rot. And then I can request a sample to confirm that if the client's interested. Here's another good sample where you can see it's very in focus. This is probably physiological spot on barley, which is a nutritional deficiency. Here's a good one where you can see bacterial blight on pea. You can see where the hailstone struck the stem. You can see it's only in the bottom half of the canopy, and the new growth looks relatively fine. These are also good ones where they use that neutral background. This is aster yellows on canola. And this one on the right here is actually a grower's nephew who was practicing taking photos through a hand lens with his cell phone. So this is ascochyta blight on chickpea, and you can see the concentric rings of fungal spores on those lesions, which is great. Very easy to diagnose. Here's another good one where you can see that that is the problem. It's going down the line. And then when they give us the situation, you can see it's just one row. And this turned out to be some compaction issues. So having that situational reference is pretty important sometimes. These are also pretty good. That's relatively in focus. We have kind of a scale of how big it is. On this one, they thought it was stripe rust, but since it's on the stubble, that's not true. This is just some sort of degrading fungus, and the next day it was gone. Here's some kind of bad ones. This one's just too dark, and the color's really off, and it's a bit blurry. So they were wondering what was wrong, and I just really couldn't tell. This one, they're concerned about the white heads, but for me, I really need to see the roots in order to tell if it's a crown rot. I could tell it's not scab, but I'm not quite sure. And then again, a situational photo, what the pattern of the field is, would have been extremely helpful in this case. Here's kind of ugly one. I'm pretty sure that's chickpea, but I don't see any symptoms on the plant, so I'm not quite sure what the concern is. Another ugly one. This guy has a really nice automotive, a nice little car there, but I can't really tell. This one's kind of really overexposed. Again, this is a chickpea. This one, again, overexposed and can't really tell what they want. This is another really bad one. Probably frost damage on pea, but I'm not even sure it's a pea. So those are some good examples of digital diagnosis. Remember to have them in focus. Take lots of pictures and send us the good ones. And that's a great place to start. Often we don't need a physical sample. This fall we'll be testing an app for diagnostic sample submission. And hopefully you'll see some press releases or alerts about that, if it works. So I also thought I'd send you to some resources about how you can diagnose things yourself. So there's lots of apps. One of the things you should be concerned about is what your source of information is with these apps. So trust things from extension. Purdue has a number of apps like the Plant Doctor. They have a Turf Doctor and Tomato Doctor, Shrub Doctor. IPM centers, USDA sources of information, APHIS PPQ, Department of Ag can generally be pretty reputable. There's a number of plant identification apps, including EdMaps West, ID Weeds. There's a Grass ID app from Montana State. And then there's a number of lucid keys for insect identification from APHIS PPQ. I tell you that with the caveat that these can be really difficult to use if you're not an entomologist, but if you're really into beetle identification, that could be your thing. Montana State does have an app for Grass ID, which we've received a lot of positive feedback from. It's called Montana Grasses, and you can find it in your store. You can browse, search by characteristics, and then here's some of the instructions. You can look overall appearance, what the seed looks like, what the blade width, and you can go in any point here and help you identify your grass. So that can get you pretty far, but if you still have a question, you can always submit a sample to us to get it accurately identified. We have a person here, Noelle Auerloff, who that's what she does. Here's a bunch of other apps. There's the Purdue Tree Doctor, and here's a few images from that. And then it brings you to a fact sheet about the pest. There's Leaf Snap. I've got one, and EdMaps West, which is an early detection and distribution mapping system. So you can actually map weeds. If you're in Florida, you can map pythons, invasive pythons with it. It's kind of cool to see those maps. If you grow wheat, iwheat.org is a place you actually, I think they've changed this to My Fields, and there's diagnostic keys. I'll give you this information with the caveat that, again, it's mostly entomologists that have developed this. So if you try to diagnose a disease, you might not quite get there, but I haven't checked it lately. Maybe it's improved. So you can go in and there's a pest diagnostic key, and what I tried to find here was Fusarium head blight, and all I found was a couple of stink bugs. So get help where you need it. The danger with apps and websites is that it's kind of like WebMD. If you go in there, you could diagnose yourself with some sort of tropical illness, but usually the correct identification is something that is much less exotic. It's usually a common cold or a flu. So you can get incorrect or misleading information. So question what the source of the information is and get help whenever you need it. I like this sign. I saw it at a meeting. We're proud that we've had no accidents in half a day. Safety is no accident. So safe. I prefer pest identification also is no accident. So take a good sample, send us as much information as you can, or bring it to your county office with as much information as you can to get a proper identification. There's lots of other apps. There's a spray calibration app, Soils Web, which will give you the soil type where you're standing. Agrian and CDMS for pesticide labels. These also include organically approved labels. There's also the cadastral data, which is online. I don't think they have an app, but that's really good to see who the landowner is. You can also keep informed digitally about pest issues. If you're growing crops, field crops, there's ag alerts. And if you're urban or small farm, you can use the urban alerts, which is mturbanalert.org. If you live close to North Dakota, you might want to get on the NDSU Crop and Pest Report listserv, and you get a weekly email during the growing season. And they have a great pest scouting program. Lots of really good specialists that contribute to that report, and I'll use that and redistribute it occasionally too because it's so good. If you live closer to Washington, you might want to, or Idaho, you might want to subscribe to the Pacific Northwest and Treasure Valley Pest Alert Network. There's occasionally useful information on that. If you're really into wheat diseases, there's a rust listserv and a wheat disease listserv you can get on. I'm happy to help facilitate that if you're interested. Here's the Urban Alert, mturbanalert.org. We put urban alerts out. You can see some of the Scudder Diagnostic Lab samples. We also put pest-specific ones. Here's one from the Ag Alert Stripe Rust. We'll include an informative title so you can easily delete the email. We also can distribute these by text. So if you go to the website, you can enter your email address to get signed up. You can also enter your cell phone to get texted when these alerts are posted. And so enter your whole number here, including an area code to get signed up. Otherwise, I'll get an error message for you. Last but not least, don't be intimidated by diagnostics. I like this picture because it's some sort of squash being very threatening. But some of that help can be found on Extension Street. And MSU Extension is here to help you, especially the Scudder Diagnostic Lab, so that you can have healthy lentils and not diseased lentils. These are a couple county agents from eastern Montana. And I like this picture because you can see where the root rot on lentil is, and Ben is a little shorter than Bruce. So thank you very much for listening to me today. I believe there is a quiz that I hope you don't have too much of a problem with, but I hope you learned something today. And again, feel free to contact me, Mary Burrows at Montana State, mburrows@montana.edu, and my office number is 406-994-7766 if you have any plant disease issues, or if you have others, I can help hook you up with anybody you might have specific questions for. All right, thank you very much, and have a great day.